Hello, NDSU LA 232 students, as well as anyone else who may have stumbled across this video. What I'll be doing is using SketchUp to show how you can help visualize conceptually ADA compliant ramps. Now, for my students, in the project PDF, if you click on this link, it's actually broken, but if you take off that last piece of the URL, starting with the %sign, and then click on the 4.8 ramps, this is the information I'd like you to be thinking about. Now, I'll come back and reference these as I start the SketchUp model, but in particular, this 1 to 12 slope is important, as is this 30 inches, which references the maximum rise that you can have for any given ramp, and 60 inches, which relates to the landings that you have to have after this rise. So once again, I will come back and reference these numbers. We will be using a handful of plugins that we talked about in class on March 25th from the class Blackboard. If you click on the organic modeling tools, that is where all of the plugins can be downloaded and installed. If you don't have those plugins, just pause the video when I reference them, hunt them down, and install them. So to SketchUp, I will be doing a lot of numeric input, so keep an eye on the measurements field in the lower right-hand corner. If you see numbers showing up in there, that means I'm typing. You'll probably also hear me typing. I will also be using modifier keys to create copies. For example, with the move tool or with the scale tool if I want to scale something about center. Generally, keep an eye on this toolbar. If I hit a shortcut, you will still see the tool become highlighted. I will try to manually click on the tools to make it easier for you to follow along. And finally, I'll be using a lot of the click, release, click methodology. Even though you can click and drag with a lot of these tools, get in the habit of using click, release, click, and that will become apparent why that's important. So to get started, I'm just going to draw a rectangle that's 200 feet by 200 feet. Typing that in, I'll hit enter. I'll be using the mouse for most of my navigation, but you can keep an eye on these blue tools to see which navigation tool I have highlighted. And I'm going to delete that surface, and I didn't mean to open that up, and create a small platform over here that is 15 feet tall using the push-pull tool and numeric input. So conceptually, I've got a 200 by 200 foot area and a small platform that is 15 feet tall. I'm going to make that a group, and I want to know how to get from here down here with an ADA compliant ramp. The really easy way to think about this, especially when it's just conceptual, is multiply your height by 14. That will get you in the ballpark of how much linear space you're going to need to create a ramp. So this is 15 feet. Well, 15 feet times 14 is 210 feet. If I draw a line down here, type 210 feet, I can see that that is actually quite long and it takes up a lot of space. Now, this is also all very conceptual. In reality, you're going to need to analyze the existing topography that you have to work with and make sure that your path somewhat follows contour lines in a way that does not require a lot of grading. But we'll get to that eventually. Let's just look more at the concepts first. Back to the guidelines. I'm going to, in SketchUp, just draw a really long rectangle. And I'll chisel this down here in a moment, but I want to talk about that slope. If you take the Protractor tool, you can create construction lines, and it's fairly straightforward. You click once at the pivot point, click once along an edge, and I'm just clicking and releasing. And at this point, you can type a number. So if I type 45 and hit enter, it draws that very conveniently at a 45-degree angle. If I type 20, enter, there's a 20-degree angle. What's neat about this is you can type 1:12 to enter a ratio or a slope. Architecture typically refers to this as a pitch. Do not do 1 divided by 12. That will not give you what you want. You might want to make sure that you do the 1:12. So that represents the ADA compliant slope. But remember, you can only have a rise for 30 inches before you have to have a platform. I'm going to grab the tape measure tool, click here, and I will type 30 inches and hit enter. So here, I can see that my ramp would start, go up to this point, and then I would have to have a 60-inch platform. Let me go ahead and erase some extra lines here. Now, if that ramp were to continue, I'll hold down Shift to add select that. That shape would just continue on until the ramp meets the desired height. With the Move tool, hit the Modifier key to create a copy, and I'll move it from that point to this point, and I'll just type 10x just to make more copies than what I need. Back to the measure tool. I need this ramp to go to 15 feet. Let's click here, start that construction line, type 15 feet, enter, and I can see that that ramp would end right at that point. So with the pencil tool, I'll draw a little line, push-pull to clean this up, eraser to get rid of the extra lines, and I still need to figure out what the width of this ramp would be. Back in the ADA guidelines, again, the minimum clear width for your ramp is only 36 inches, which means it would look about like that, minimally. Anytime you have a platform, more times than not, you're going to want that to be 5 feet. You really only need it to be 5 feet or 60 inches if you're changing directions, but it's a good idea just to be safe. Make it 60 inches all the time. The reason for that, 5 by 5 feet is the amount of space you need for a wheelchair to comfortably do a circle. So there's 36 inches, there is 60 inches. Typically, I like to draw everything or create ramps at 60 inches wide. There we go. Now I can erase those extra geometries. So if we were to just bolt this onto that platform, let me make that a group and go ahead and move it. I'm going to do this. With the scale tool, I'm going to scale this about center, holding down Option on Mac, Control on Windows. Just invert it arbitrarily. After you've completed that, you can type -1 and hit enter to get a mirror of that shape. And let's just say, for example, if I were to bolt that on, it would look like that. Not very creative, but conceptually you get the idea of what kind of ramp you would need to get to this point. Now, I've shown before a real simple way to create a ramp that only really works if you very conveniently have a really subtle curve, such as this shape here. If I grab just the end point in the Move tool and snap that down, so that works really well for very subtle curving, one arc ramps. If I take a look at my hidden geometry, you can see that it's quite simple. That doesn't work as soon as your curve gets too curved or if it starts switching directions. Let me go ahead and delete that. But conceptually, that's the same thing we're going to do with this shape. Using some really nifty tools by Chris Fullmer. He's a really smart SketchUp guy, and one in particular is called Shape Bender. For this tool to work, you need 3 things: a group, a line that is aligned to the red axes, and a path that you will stretch or bend this shape to. So let's go ahead and add those. You need this line that I'm going to place on the center of this shape. Again, this is a group, that's very important. This line just needs to align to the red axes, and the tool uses that to match up with the other line. Well, let's just pretend that we've got a really curvy path that starts here. Now I'm kind of keeping an eye on this 210-foot line because I want this to be close. And I'll arc that, and then I'll arc out here. So if I grab those, do a get info or entity info, 214 feet, pretty close. So now what I'll do is just shave off 4 feet by drawing a little helper line, hit escape, and then erase, erase, erase. If I triple click on that, 210 and some change, but that's good enough. So that's the shape that I'm going to bend this to. Here's how you use the tool, pretty simple. Click on your group, activate the plugin, and you'll be prompted to select a line that lies along the red axes, which I can kind of see right there. At this point, again, I'm using the click, release, click method. If you toggle your down arrow, notice how the start and end of that line changes. So you can specify where's the start, where's the end. This is important because this tool takes a little bit of practice to get right, and you'll see why here in a moment. I'll just keep that at the end, that at the start, and I'm going to click on my shape. The plugin thinks for a little while. And at this point, you'll see a green frame that is showing you what the shape will look like. If I were to click again, it would confirm that shape. But that's not right. At this point, I can use my up arrow key to toggle the start and end of the shape that I'm bending to. Now, this is a little bit, again, trial and error. If it doesn't work after a couple up and down arrow clicks, notice that kind of looks right. Something got messed up down here. Let me try my down arrow key. Sometimes it just works, sometimes not so much. All right, I'm going to click on my arrow key to exit out, and what I'll do is scale this thing back to what it was at. So with the scale tool, hold down the modifier key, just arbitrarily invert it, and then type -1, then enter, and we'll try that again. Shape bender, click on the line, click on the path. That looks much better. When it looks good, you just need to click or press enter to confirm, and it creates the shape. Now, sometimes there's a little bit of cleanup. This isn't so bad. I've still got my hidden geometries turned on. Sometimes you may need to unsoften the start or end of that. Mine actually looks pretty good. If yours does look a little weird, for example, let me soften an edge. It might look like that. With your hidden geometries turned on, you just need to right click on a shape, click on unsoften, and exit out of that component. There we go. Now I can snap that into place, and I've got an conceptually ADA compliant ramp complete with platforms. I'm going to take this line that's still down here, go ahead and move it over here, and create a couple copies. Well, I'll just do one copy. Because this tool does not have to have matching lengths. I just showed that for an example because I wanted to consider the ADA numbers of having a certain rise and a platform, etc. But conceptually, all we really need to know is that it starts at a point and rises to a point. And what is that? Well, if I start drawing a rectangle and I'm going to type, I'll just do, say, 30 feet, comma, 5 feet, hit enter. And I will raise that 15 feet. Take the pencil tool and push-pull this. So this gives me a ramp, a very simple ramp, but conceptually I can do the same thing. I just need to stretch this shape to match that curve. And because I'm not worried about these platforms, this will work perfectly fine. So I'll just do the same process again, make that a group. I want my line to go from here to here. You can see that easier below. And I will go to plugins, shape bender. This time I need to go underneath to click the first line, click on the path, and you'll see it doesn't matter what shape or the size of this shape. It just stretches it to fit the source line that you click on. Hit enter to confirm. There we go. Now this slope, I mentioned earlier, the 1:14 ratio, that factors in these platforms. Back on this shape, with my Protractor tool, I'm going to draw a construction line, and this time I will type 1:14, and you'll see the end result is the same. So that's helpful to know when you're just visualizing or considering where these paths would go. You can come back and massage in where these platforms are at. That's not required for my project, for my students, but just generally good to know. This tool gets a little bit cooler though, because that works well for this kind of shape, but let's say, for example, we wanted a 36-inch handrail. I'll draw one line there, 36 inches, draw one line there. I'm editing this group. I did that rather quickly, but I double-clicked to start editing. And let's just make a copy over here. I think I gotta close off one face. Exit out of that component. I'll do the same thing. Click on the group. And you know what? You may also have the shape bender tool active. So if you see this, that's the same thing as navigating to the plugins. Click on the shape, click on the path. Now that does take a little bit longer to process. I sped it up through the magic of post-processing, but you can see that it is included. Rather than hit enter to confirm that shape, I'm going to escape out by clicking on my select tool and mix it up even more. So what I'll use is a tool called Scale and box tapering. Scale is a tool created by a SketchUp genius who goes by the name of Frito6. Really cool stuff, definitely recommend it. Box tapering, let's go ahead and create that kind of shape. So what do you think will happen if I apply the shape bender tool now? Path, shape, hit enter to confirm, and there we go. Pretty cool stuff. So that alone is enough ammunition to create some very integrated ramps. This all works very well, of course, if you have access to these plugins and know how to use them, but it's also valuable to know how to more traditionally craft this type of ramp. And a couple other numbers that are important to consider. We know the slope is 1:12. We know the platform is 60 inches. The math on that works out interesting in that this is 5 feet and this is 30 feet, or that becomes 1/7 of this whole shape. What does that mean? Well, any distance you need to cover, for example, 210 feet, 1/7 of that is probably going to be platform. 6/7 of that will be the 1 to 12, if that's the slope you're going with. And that becomes important when you're thinking about ramps such as this more traditional engineered zigzag ramp. It's a very efficient way to get from point A to point B as quickly as possible. Well, let's say, for example, you're thinking about a ramp that might start up here and zigzag down like this. There's a platform, slope, platform, slope, platform, slope, etc. And you want to try to do that with 4 sloped areas. Here's how you think about that. Your total distance is 210 feet. And 1/7 of that is 30 feet. Which means you're going to have 180 feet of sloped ramp. If you wanted to try to get by with 4 sloped runs, that means each run would be 45 feet. But because you know ADA law, and your run shall be 30 inches in height, which translates into 30 feet in run. 30 feet is less than 45, so that won't work, unless you wanted to introduce some platforms in the middle of that run. Let's try 180 divided by 6. Well, that conveniently is exactly what the maximized slope and platform would be, which is very similar to this. 30 foot, 60 inches of slope or platform, 30 feet, etc. That's not very fun, so let's try divided by 8. 22.5. So if we have 8 sloped areas, which I think is what is shown in this image, each run would be 22.5 feet. So I'm not going to use any special plugins for this. We'll just use good old SketchUp. But I will use the tape measure tool to first draw in a 5-foot area, then a 22.5 foot, oops, I did inches, 22.5 feet, and then another 5 foot. Platform, slope, platform. If I rotate around, grab the rectangle tool, start here, just get that going in the right direction, and now I can type 5 feet, 5 feet. And I will take my Protractor tool, just like before, click on the pivot, click on an edge, start in the direction I want to go, and I will type 1:12 and hit enter. So there's my platform. It will slope down, and the platform will again continue here. Tons of ways to do this, so I'll just show you one that I like to use. I'm going to make a copy of that shape, so I'll grab the move tool, hit the modifier key, move it right down to here. Then with the pencil tool, I'll just connect a few lines, and there's my first of 8 ramps that I'll need to get from the top of this to this area that is 15 feet below. Well, I could draw some more construction lines and do that thing again. There's a little bit easier way to do it. Let me erase those. I'm going to also erase that dimension. I'll select that, and I will make a copy, being sure that this copy is not touching anything. Notice how it's not overlapping. Then with the scale tool, hold down the option or control on PC, just arbitrarily invert it, and then once you've done that, type -1, enter. We have a perfect mirror. Now with the move tool, I will snap from this edge to right there. If I need 8 total, I just need 4 of these, since each one has 2. So I will select those, move tool, click there, make sure you have the modifier key to make a copy. And that is the first copy. I need 3 additional copies in total, so I will type 3x and hit enter. And there we go. I can see that that does align perfectly to the ground. and just another more engineered option to navigate from point A to point B. Once you understand and are comfortable with these very basic ideas, you can start to get creative. For example, if I select just those shapes, I'll take the rotate tool and I'll rotate that out like that. Then I'll take these shapes and I will rotate out like that. Now these platforms don't change. Notice I can delete those edges because they are coplanar. Oops, I messed up right there. Wasn't being careful, but you get the idea. You can see how you can go from a very engineered solution to a more designed solution that might meet the topography a little bit better, or otherwise be more interesting and make your ramp look less like a bolted-on addition and more of a part of the design. For example, here is that zigzag option that we quickly drew in. Well, it's not a far stretch to create that than it is to create a stramp, which is kind of a very neat integration of a ramp and stairs. You have to check on your local laws to make sure you can get by with this, but not a bad idea. Or another example of this ramp is 1 to 20, so it doesn't have to have a platform every 30 feet. Someone could take the ramp all the way up to this elevated area, or they could take this other option that has a series of stairs that end up in the same spot. It's a very mathematical solution, but not in the least an engineered solution. And another example I've got to show here is this ramp zigzags up this platform and has a series of stairways that meet this roadway that also happens to be sloping. You can't quite see it off the edge, but that goes underneath the road over there. One thing I didn't show was stairs. Stairs are not necessarily an ADA thing as much as they are an OSHA or local code thing. For conceptual purposes, a good number I like to use is a 12-inch tread and a 6-inch riser. That's convenient because you can quickly figure out how many feet you need to accommodate with that shape. So with my 12-inch tread, 6-inch riser, I can create a copy. There's one copy. Because this height is 15 feet, I would need 30 total. It's not counting the first one, so if I type 29x for a total of 30 copies, now I can take my pencil tool, connect some dots. Again, not a ADA thing, more of a local code thing. And I believe OSHA says every 12 inches or every 12 feet of rise, you need a platform at least. So, easy fix. Let's just do that. There's my platform. Now, I'm not requiring for this project for my students that you have to include stairs, but I don't want to discourage you if you do want to include them. Again, this is all very conceptual. You would really need to study and understand your topography at the first step when you first create this pathway. But understanding all of this together really makes the process easier, and it's much more conducive to creating integrated, thoughtfully designed ramps rather than bolted-on solutions. With all of that, I hope you are well on your way to creatively designing and integrating ramps. Let me know if you have any questions. Feel free to ask questions in the comment section, or you can email me, and good luck.